Hi guys, welcome to another video on this series of coding videos. So if you remember, we are trying to see if we can get rid of all the elements that we still have left on the formatable space. I was in two minds whether to do this video or not, because this is progressing a little bit slowly because of talking while coding. So I'll just give it a go trying to do this refactoring, see how it goes. I might have to skip a little bit, do some work without recording if the speed continues to decrease, but at the same time it would be interesting to show this work, because I think it's a very good way to demonstrate what we tend to do when we're doing Dogen work. So what we did, since you left us with the previous video, was we removed the configuration for locator. We already had added all the bits and pieces that we needed, all the bits and bobs that we needed over to the project path properties. We had updated the Metamodel Properties transform to do the right thing and populate these guys. And now in theory, all we needed to do was to go to the text model for C++ and start to make use of these properties. This is just a way to validate that we didn't break anything. So while you were away, we started that work, and pretty much everything in the header file is done, I think. Now we just have to go through the CPP file and try to get this thing to compile again with the properties. So let's just look at where we are. So we're looking for a facet here. I mean, there's a certain amount of refactoring we're going to have to do. We're trying to minimize that certain amount of refactoring. For instance, I think this configuration for facet is taken in. Okay, so it's been called from here, and which has been called from here, I suspect. So make full path for include facet, make full path. All these things are taken in an archetype as a string. Now that's interesting. Clearly when we did the identification refactor, we did not bother to update this legacy code. Now just for a laugh, if we have a quick look at how this thing is being called, yeah, as you can see here, what we do is we unpack the physical meta ID to extract the string inside of it. Part of me wonders whether we should just do this properly and actually just take, instead of a string, take a physical meta ID, the proper identification type, and then just propagate it all along, because no, in fact that's probably not worthwhile doing that, because okay, that would be the right thing to do, but you have to remember that we're trying to remove the locator, so don't really care about this code in the end game. We just care that we validate this thing works. So all we need to do is to make sure that when we create the transform, that we do the right thing in the transform. So that's not really impacted by this. So we can just stick to what we got right now. This is going to look really weird because the hackery will continue here. What we need to do now is we need to now say something silly like identification, Portuguese keyboard entities, physical meta ID, ID of the facets. As you can see here, what we just did is we unpacked, and now we're packing again back into a primitive. It's not really very nice, but bear in mind this is just temporary. So we're gonna take our container, do a quick search for this thing, and then if we find it, we will return the right thing, and there you go. So this is really not very nice, but it's not that important in the grand scheme of things. And in here we got a similar problem, and I think I might just use my coding gloves. These are helpful if you code for very long periods of time, as unfortunately I have done all my life. It seems to be more of a problem in the winter, where your hands start giving you strange pains. It's fine in the summer, really. So what we want to do now is something similar here. We've got an archetype. We've got some kind of Metamodel Properties for the archetype. Something is happening downstairs. Okay, that's now resolved. So where were we? Yeah, so what we're trying to do here is trying to look for the archetype. No, not the archetype, kind properties. Hopefully there'll be some kind of archetype property somewhere. And so you can call these archetype properties. And we're going to have to do something very similar here. This is one of the difficulties of programming, really, is that you have to make these kind of really strange decisions where you must not... It's a bit like climbing in a way. Programming is a bit like climbing. I'm not much of a climbing expert, if I'm honest, but you can climb a very big mountain by moving very slowly from one bit to another. But if you try to just go a bit too quickly, you will end up having a problem. You won't be able to go very far if you do that. So sometimes you have to go sideways in order to go up with programming. And it's always disappointing because every program will tell you this. We try very hard not to go sideways because it just feels like you're wasting your time. But in reality, it's much, much quicker if you do that. You have to go through this phase of trying to do this massive jump, fail, and then realize actually I should have instead just gone slowly but surely. I think we all have to go through that. Even experienced programmers. I mean, I've been programming for a very long time now, and particularly on my private projects, because the thing is, you have to remember when you're coding at work, the nature of coding from an open source project versus a closed source project is very different. It's very interesting, actually. I probably should blog about this at some point. It's not necessarily the case that everything is rosy on open source projects. You have got different kinds of challenges. For example, at work we have a lot of resources, and that means that there's multiple people per team, and you have lots of things that are available to you. So let's just make sure we know what we're doing here. Whereas in an open source project you don't have many resources. So let's just make sure we know what we're doing. I think this is made static, that's why. Yeah, in an open source project you don't have so many resources. Okay, now we're gonna have a problem here. So we're trying to make a project path. Supposedly that's a static function, but we need clearly access to the output path. Now, because we are doing this probably from the constructor, I don't really like constructors that call non-static functions. The reason why is because you start making these weird dependencies in state. So you can see clearly here that we're taking the output directory path here, and we are also calling the project path, which needs the output directory path. So really what we want to do here is we want to supply the output directory path as an input to that function. So somewhere around here, make project path, this guy here. Yeah, it's very easy to introduce subtle errors on these kind of functions that are called by constructors that then depend on state. And I guess everyone has to do that a couple of times until they become really wary about what you're doing. If we do something like this, I think that should be a bit more helpful. I mean, remember, this is all temporary stuff, so all we need to do is to make sure this thing compiles. It doesn't have to be the best thing ever, as long as it does the right thing. So, if we get the model name, so what we really want here is the model modules. and that will be available in the PM.provenance presumably. There's going to be a logical name here that will contain the model modules. Yep. Just about fits in our. Right, so now we need to know where the backend directives have been enabled. That we'd be able to do that by saying enable backend directories, PM. Presumably that's going to be in project. Metamodel Property, of course, and then the projects. Actually, it may even be here directly. Email, backend. No, it isn't. So it will definitely be in the project properties, presumably. This data structure, as you can see, these data structures are becoming a little bit too convoluted, really. It's a sign that we have done not a particularly brilliant job in the modeling. But, like I say, one thing you must always remember is that continual refactoring. You shouldn't really get too lost in this perfect state of the world. Remember Voltaire. If you get too focused on the ultimate end goal, you end up not actually doing anything. Part of engineering is really the experience of doing things, and without that experience, you're not able to get to the end state. Now, let's just try to understand what we're trying to do here. This is now asking me for some kind of local configuration, and in the local configuration we're going to get the backend directory. I assume, well, let's just have a look at what PPP has. No, so the backend directory name, we have seen this somewhere. Right, so why can I not spot the backend directory name? It's not here. Ah, okay, so we have backend properties. Now, we just have to make sure we have our backend somewhere. Let's call this a backend name. And I think, sadly, maybe we should call this a backend ID, because I think we're going to have to do something like Dogen identification, entities, physical meta ID, presumably. And that's going to be the backend ID. Now, I think what we need to do, if I'm right and I'm understanding this correctly, well, still a fair bit to go. If I'm understanding this rightly, we need to obtain the backend configuration. So that's going to be something like backend properties. So we just do a find here and the backend ID. Right, so that should be fine. So I'm just going to say const auto by reference backend properties, and then just do a quick bp.find backend ID, and if bp dot of course this should be const auto I, some kind of iterator, if I is equal to the pp.end. Of course, what you're probably going to tell me now is this is a bit silly, isn't it? I mean, yeah, but to be fair, we only need to do this once, so who cares, right? We can do this every time this function gets called, because presumably once we make the project path, we don't really need to call this function anymore, right? Correct. Okay. So what we'll do is we won't care that we're actually doing a lookup in a map. We'll just make sure we do the lookup. Could backends, and then we'll just have this chap here. And now we have this chap here. We could easily then say, well, we expected the backend to exist, so one thing that we should really try to look into is how do we do a find that must succeed, sort of a strict find. There must be a way C++ to do this. We keep doing this. Is a pattern that's very, very common in Dogen. Look for something that you expect to exist, if not throw. There must be a C++ idiom for this. There must be some function in STL somewhere that does a strict find that expects a result. However, we haven't quite found it just yet, so for now we're doing things the hard way. And it's a bit painful. A bit boring, really. Now we're probably going to need some I/O for identification. This chap here. Okay. So then we expect I to give us the backend properties. And then of course we expect to have something like a const auto directory name, shall we say. And that could just be I dot second presumably. Directory name. And then we can simply say that if the dn is empty, now we have a problem. Otherwise, take the dn. And you can see here it's a very simple logic. All we've done is we queried the Metamodel properties to obtain the data that we needed. Now we're going to have more of the same, I suspect. Right, so here we are doing a look for the archetype. So I suspect this is going to be very similar. So right, see, here we're doing the backend properties. Here we're going to do the same thing, but for the archetype. I assume there's going to be something like an archetype properties. Archetype properties, there we go. So, the problem is, of course, that we don't read. Okay, so this is the facet path is actually occurring at runtime. Not at runtime, but after construction. So at that point we already have an object with some sensible state, which means we can just rely on the existence of the physical model. So we can say something like go to the Metamodel Properties, and then let's locate in the archetype properties right, so unfortunately we need to create it yet again. So you can see all this packing and unpacking into primitives. And the only thing I can say in my defense is that we have to just do this, just to get on with it, because none of this code is really going to live very long. So whilst it's a bit annoying, one must not get distracted by that. Now let's have a look. Are we really using this type quite a lot? Because if we are, we should just do a using for it. Yeah, we're going to be using this a few times. Just say using. At the top level, just to save us the trouble. Usings are fine in the CPP file, particularly with the names that we got in our types. It's so expressive. I mean, just to make sure you don't do them on your header files, but other than that. So there you are. We have a using for the archetype, for the ID, Now we pack this back into a primitive. We do a find for the ID, and then as usual, if we can't find it, we get very upset. Well, this could really be encapsulated into proper functions and so on, so we just have to bear in me, remember. All the temporariness of these codes. So what we mean to say here is missing archetype. Probably need to come back here, leave a mark. Okay, cool. Right, so we're missing an archetype. Right, so there we are. And it's not really very happy because this is a primitive. Right, so we expect to see the archetype. So what we're going to do then, we're going to locate for the configuration of the archetype. Now we have to pray. Okay, so now something has changed here. On the configuration previously, from the archetype, we could easily find the facet. So you can see here there's a problem. We can't now find the facet properties from the archetype properties, which is fine. We have two options here. We could either say, well, what is the facet for this archetype? Do another lookup and obtain that. Or we could do the same hackery that we did previously, which is to just flatten, denormalize, as we've done in other places, as we called it in other places. Denormalize the type. So let's have a quick look at what we did for the locator configuration. See, as you can see here, facet directory, facet postfix. This is basically a denormalized thing that contains all the stuff we need. Just to save us from having to do n lookups, we can just do the one lookup for the archetype. What is the easiest thing to do, given where we are? Because remember, this is just temporary, so we just need this thing to work. And even if we add the archetype, how quickly can we get the facet out of the archetype? We could use the physical metamodel to get the name. We could construct a facet, but sadly we don't really have the full archetype properties here, so it's not very easy to navigate the logical space. So let's think about this for a second. How do we find a facet given an archetype? We also have other properties here, such as disable facet directories, which in the new world, where would that be? Okay, right, so that's easy enough. We can just go to the project path properties for that one. Key thing really is how to get the facet directory. And then we have the actual archetype properties, which we can easily get. We just need to get our hands on a facet for this archetype. So, okay, how do we resolve an archetype to a facet in a quick and dirty way? The physical model does not have the physical metamodel, which means the locator doesn't have that. The physical metamodel contains everything we need, because if you were to look at it, you can easily see here, the archetypes are here, and the archetype, if we had an archetype ID, we could easily go to the metamodel and say, well, for a given backend, find me this archetype. And once you've got the archetype, then you can have a proper physical meta name rather than an ID, and the physical meta name could easily be used to construct a facet ID. So we could do that. Seems a bit of a lot of work just to resolve the archetype to a facet. We could also hack the physical model, and we could say actually the archetype properties could then have a denormalized version. So we could say that these guys here could have a facet directory name. And in fact, to be honest, if we think of this logically, this may be the right thing to do. Denormalizing the archetype properties to contain the facet properties as well is probably the right thing to do, because we will need this on the ultimate destination. We will need facet properties in order to compute a path when we got the archetype, and it will just save us from having to do lookups. Because if you think about it, what is the transform going to do? The transform is going to basically say, let's iterate through regions in physical space. Each region belongs to a logical model element and will contain a number of artifacts. These artifacts belong to archetypes. So for each archetype, for each artifact, we need the properties of that archetype that artifact is an instance of. And then at that point, what you're going to be doing is you're going to be then saying, okay, now try to compute the path of this artifact. And in order to compute the path of this artifact, you're going to simultaneously need the backend properties, the facet properties, and the archetype properties. Backend properties obviously are going to be common to a whole lot of stuff, but what we cannot do is we cannot loop. So in an ideal world, you loop for each backend, for each facet, for each archetype, such that in the loop you'd be iterating to physical space. The reason why you can't do that is because the regions in physical space are organized by logical regions, and the logical regions themselves are going to be a jumble of different facets. In order to reorganize the regions of physical space such that we group by backend properties and then facets, we would have to have a different geometry of physical space in the model, and that geometry would have to then be artifacts by backend by facets, and eventually of course we'll have parts. So you'd always have to loop. There's no easy way of knowing where you're going to be. So really what we're concluding is that the archetype properties should really have a path where they contain, and in fact once you start saying that, you start to wonder whether you need to separate the facet properties, backend properties, and the part properties at all, actually, because if you think about it, we most of the time, so there's 2 points in which we need to think of the geometry of physical space when we're computing enablements and we're computing paths. But most cases, really, we're basically trying to say, really, what we really care about is the archetype. These things are important because we need to get them, we need to get at them. We need to first obtain all these things, we need to compute them, etc., and so forth. But then once we've done computing them, we never really worry about facet properties, really. We never worry about facet properties in isolation. It's always in the context of an archetype. So that makes me think that actually, and this is what I meant before about why you need to write everything down, and then you start to think about these things a bit more deeply. What's becoming obvious here is really this. The ultimate destination, the thing that we use for computations, is going to be an archetype properties object that contains these 3 things, all nicely ready for use. There's an interim state whereby we obtain these things separately, but then the ultimate destination of the thing that's going to be preserved is going to really be this guy containing these 3 guys. And we don't really particularly care about having backend properties, facet properties, and so on. Let's just have a quick look at how the enablement transform is working at the moment. I should think we will see see, the Enablement Transform at the moment is doing some reading. Yeah, as you can see here, what we're doing here is we are obtaining a feature group. See, this Enable Transformer has not been updated yet, but you can see clearly what's happening here is exactly what I said. You have a denormalized thing. Let's make sure we're not dealing with some kind of legacy transform. No, so really this thing is has not been updated really. This Enablement Transform should be working in terms of Metamodel properties. And as you can see here, the Metamodel properties that we really care about is the denormalized Metamodel properties that I just mentioned. And if we were to update this transform to do the right thing, then this thing would not exist. We would just read the Metamodel properties, and then what we do is artifacts by archetype, and then see what's happening here, right? What we're doing now is we're trying to say facets. What is actually feature groups, right? Okay, cool. So what we're trying to do then is we're trying to read the properties. Yes, we're trying to read the properties of each artifact. And now we're going to populate the enablement properties of the artifact itself. By reading them from the metadata. And these are going to be what we call the local properties. And to be fair, yes, there's a problem here, of course. The problem is that we have local and global properties. The global properties are properties of the archetypes, the facets and so on, but this can then be overridden locally at the archetype level. That's why we need to reread them again, because first we read it from the global configuration of the model, and then we read them from the individual configuration of the archetype. Now we can't get away with that, without doing that. We need to do that. But what we can get away with is when we are looking for the properties of the facet, and you see here exactly. So now everything is making sense. So you can see clearly what's going on here. We have sort of it's a three-step process. There's the global version of it, and there's the local version of it. Now, what we do is this: we first read each of these properties separately. The ones in the Metamodel properties are global. The ones in the artifacts are local, right? These properties get read, then they get denormalized, and then they get computed, which is fine. It's a very, very simple process, really. But if you think about it, another way of doing this would have been to say, actually, read them and create a denormalized version immediately, then compute. Right? Why would you have to have a two-step process where we end up storing the intermediate state when we already know what the end destination is going to be? And the end destination is basically that I just need the denormalized global archetype properties. I don't particularly care about the rest. We just ended up doing the denormalized archetype properties for the enablement, but actually the same thing applies to everything else. We still need directory names, we still need everything. So really, what we're trying to say here is that we should probably have some internal state with the backend properties, the part properties, and the facet properties that is used to in the transform, the Metamodel properties transform, and then we just compute the one thing and supply that one thing to the enablement transform and to the locator as well, because they have similar needs. So that's easy enough. Not quite what we wanted to do right now, but it makes sense. So we just have to make sure we don't break anything by doing that. So let's think about this for a second. Let's have a quick look at the Metamodel property. This is very hard to do whilst recording. So if we look at the Metamodel properties transform, So largely, all this thing is going to be doing is really just reading stuff from configuration, more or less. So really, what we should really do here is we should probably say, in fact, there shouldn't even be a notion of denormalized archetype properties, really. We should just have archetype properties, which is composed of these three guys. And what we do is we internally create the facet properties, backend properties, whatever, in a container. Then we just loop through the container, find the facets of that archetype, find the backend of that archetype, find the part of that archetype, locate the properties, populate them there, and away you go. So it's the second pass. So what we're going to do is, before we get more confused here, let's just create a story. Create denormalized representation of archetype properties. And we still don't have proper support for tagging for some reason. So at present we have a two-step process. We first read the configuration, the global configuration for a model, create the corresponding properties, e.g. backend facet archetype properties, and then we post-process these to create the denormalized, let's just copy the denormalized archetype properties. However, we never really need to think about the individual properties because they are always used in the context of an artifact, which means we care about the denormalized archetype properties only. Therefore, we should have archetype properties that is composed of all other properties. Change the Metamodel Properties transform to create internal indices of properties as a first step for the final property generation, but do not expose these containers. Okay, so that I think will solve that problem. Now of course you may already notice that we need to solve this problem before we can continue with the locator work. Reason being that the locator will require these denormalized properties, and so now what we really want to do is to get rid of this guy, merge all of these, change the transform, and this again you can now see what I mean about this kind of work being really strange, because really the ask here, unlike professional development, the ask is this continual refactoring is the ask, because what we're trying to get to is we're trying to get to the final conceptual model, and to get to the final conceptual model we have to get to the right data structures. So whereas in a normal software house you have a goal, which is to finish something for an end user and get some feature and functionality working, which makes it really easy in a way, because sometimes you can get away with modeling that's suboptimal because you need to develop a feature. So you do some modeling, you do some code reviews, you do some work like everybody else, and you try to do your best. But the thing you measured by is the fact that the feature works and the end user, the business user, is very happy and it does what he wants it to do, or she. In this work is not quite like that. The refactoring is the end goal, because the objective here is to create the conceptual model. So therefore, it's not just the case that I could just go and quickly hack this, because if the conceptual model then is completely incoherent, then we have failed in the ultimate goal, which is to create the conceptual model. So therefore, this continual never-ending refactoring, sadly, is actually the ask. Which means that now we can't really do this locator work until we figure out how to denormalize these properties. Because just to remember what we've done here is we need to access the denormalized properties in order to compose a path in the existing locator. And the right way to do that is to denormalize the properties into here. Because that's how they're going to be used in the end when it comes to the new world. We can get away with something like this because we know this is temporary, but we can't get away with now creating a denormalized structure as a hack, because when we come to the end, the final refactoring, then it's not going to work. So what we're going to have to do then is, and this is sadly what tends to happen a lot around here. Actually, I forgot to start clocking here. We started around 9 o'clock, probably 9:01. And what we're going to have to do now is we're going to have to pause this work and quickly hack the refactor. But this can be done just by remembering where we are and then saying something like, oh, actually we don't want to do that looks fine. So let's just say locator refactor. Now we just have to be careful. All we've touched here is stuff related to the locator, configuration and so on. So if we just stash this for a second, and if we could just build a code generator that has the previous state, we must not touch the CPP model. It'd be nice if we could. I wonder if I could change the color. I'm just gonna. Yeah, okay, that's interesting. So now that should remind me. I mean, red is might be a bit too extreme, to be fair. If I change to some weird color, that will ring a bell immediately. Okay, these colors are really strong. We need some pastel-like colors. Just has to be different. Right, the brain should pick this up. As soon as I see this model, I should remember that I should not change this model. Now that should be enough for us to remember we're not supposed to change that. And then what we're going to do is we're going to very quickly refactor what we need to refactor here. I think we didn't really push. That's fine. What we should have actually, sorry, I'm just going to. Okay, it's not very happy with that change, I'm afraid. We must have done some changes that were not. Right, so this is really not ideal. Let's go back to, so it's very important to always make sure you save your stuff before you start modifying it, because otherwise you may end up in a bit of a state. Right, let's see how much diffs we get if we do this. Yeah, still quite a few, you see. In fact, far too many. Right, so what probably happened is it's not looking like the kind of diff I'd expect to see from this model, if I'm honest. I've only changed a couple of things, and I'm pretty sure I'd saved it onto that. So what we're going to do, this is a bit confusing, but what we're going to do is let's just close a few of these models. And then I'm going to stash these changes. And let's just go back to the locator refactor as it was. And let's have a quick look at how the model looks like. Now, if I'm right, keep clicking on everything except the thing I mean. If I'm right, I should just expect to see, yes, okay, this is good. And now we can change this guy to say some other color. Doesn't really matter what the color is. And now, don't expect much changes here. Now, I don't really know what changes we had over there. We just want to make sure we reset this guy. So there's a few changes that we got in that stash here that we have no idea what they are, but everything is recorded there. So hopefully we should now end up in a good state. This is the magic of Git. I quite like Git, really. So let's go back to what it is that we're trying to do here. We're trying to now change the Metamodel properties, in particular the archetype properties. We're going to, and hopefully this will work, we're going to take away, I mean, the part of me also says there is no problem of keeping this intermediate state, facet properties, you know, a container of facet properties by ID and so on. That's not a big problem, we can keep them. But we should only keep them if there is an actual need for it. So in other words, if no one is actually consuming those facet properties, we don't really think we need them. We don't really need to carry that across, you know, ad infinitum. So we first need to figure out if there is any user for those types. Outside, of course, the actual construction. Okay, so there we are. Let's just construct a built a code generator that looks vaguely sensible. Test pass. We're good to go. Now then, quickly check. If I just go to the, this is where I think LSP is useful. Metamodel properties. So if I just take this guy here, for example, and if I say LSP find references. Now, all we want to do here is we don't particularly care about itself. Right, we know for sure we need it on Enablement Transform, but that kind of makes sense because that's what we're populating. Actually, we're looking for the wrong thing. Sorry, I didn't really mean to look for the Metamodel properties. What I meant to look for. Where are we? Oh, we're model, not quite where I meant to be. Workspace symbol, Metamodel properties. What I really meant to do is to look for Metamodel properties. So now, say I take one of these types, like for example, the backend properties. Sadly, because we have so many overloads, this does not make it so simple. But let's just have a quick look at the simple case, right? As you can see here, what's happening here is itself, its IO, itself, bingo. What's this? That Metamodel properties transform, okay. And I bet you it's going to be the same for all these guys here. These are mutators, and if I look at the facet properties, lo and behold, it's going to be Metamodel properties, the IO, Metamodel properties, the Metamodel properties transform, and interestingly enough, the adapter. Right, now that is important. The adapter seems to need the facet properties. Now the reason why this adapter is going to need the facet properties, believe it or not, is purely because for the moment, right, this is just a temporary thing. Okay, so we can't actually remove it just yet. Of course, like I said to you, you can't really keep on refactoring forever. So we can't. Let's put a note here. Don't know why. Right, notes. We can't remove the top level containers just yet because they are used within formatables. Namespace. However, these appear to be legacy use cases, so we should be able to do so when we get rid of this namespace. We'll just leave this note here because clearly we'll need a story later on for this. So, to cut a long story short, we're not going to be able to get rid of this just yet, but as in we're not going to be able to get rid of the main containers just yet, but we will in the future. So what we need to do is to design this model as if we were in the future. And the way we do that is very simply as follows. We also had another bit that needed a bit of hackery here, which was the extraction properties, if you remember. So we will just tackle two things in one go. First thing is going to be the extraction properties, because it's easy. Let's just have a quick look at... Yeah, you can see this model is up to date. So what we're going to do is we're going to take the extraction properties. So the extraction properties are header file extension, C++ headers output directory. And alright, we've started doing that work. So you can see here headers output directory is already there. And I believe we already are populating this. So let's just have a quick look at what happens when we start to get rid of this. Sadly my memory is not quite where it used to be. I'm sure we're doing some stuff on extraction properties a second ago, but lost the plot slightly. This is another difficulty of having sort of a full-time job, more or less full-time job, and doing these things on the side. It's not so easy to put the state, especially when you're doing something non-trivial like code generation is. It's not exactly easy to remember where things are, and then of course you flush the cache every Monday, and then have to remember it all on Friday again. Right, here we are. So we have the extraction properties transform, which is reading this guy here. And that's not doing very much, so I should think I don't need that guy anymore. Let's get rid of it for now. So what we do is we're just going to look through all these errors that we create. Get rid of all of them. At some point, errors are going to stop. So cases where we are referring to the extraction properties now, we should really be pointing to the new guy. So the extraction properties, trying to obtain the headers output directory, and that then is supplied. Now then, so if everything is going according to plan, what we need really is our PPP. So it's mmp.project properties.headers output directory. Oh, actually, we just need the PPP here. And then let's call this the headers output directory, and that's just going to be the pp. I don't know why I call it the PL. PPP dot headers output directory, which is this guy here. And now, if we did read the headers output directory correctly, the test should pass, and if we didn't, then we need to figure out why we didn't read it correctly. Okay, it actually doesn't look too bad. Let's just try to convert Dogen.physical.div to JSON. Of course, we should really have targets for all these things. Problem is, we don't really have enough hours in the day to do all the optimizations one should really do. To our workflow. What? So now then, try again to read. Oh, I forgot that we don't have compilation here. Try again to figure out what's going on here. Soon enough we'll have a green area. So that's the end of the extraction properties. Make sure we are working from the latest code generator. Let's go up to Git, and we can now say physical remove deprecated extraction properties. Okie doke, and that's good because we got rid of extraction properties, which we meant to do for a while. We haven't pushed in a little bit. Should probably push it around lunchtime today. Right, cool. That was good. That was really good. And now the second bit was going to be we're going to move the archetype properties here, and by a sleight of hand we are going to make this guy look as if we are already in the end game, which is to say we're going to get rid of the dependencies we have the model and put them here at the top as if they were only related to backend properties. So we probably want to create some space here. We do spend a lot of time playing around with modeling elements. There we are, something like this. Now then, what we're going to do is we're going to say, well, how low can we go? Perhaps as low as that. Need some space in the middle somewhere, and this guy will go here. And this guy will now say something like this. Backend properties, facet properties, and parts properties. So you see now the archetype property suddenly becomes the normalized version of itself, and we know for sure that each backend only has one part, it is in the hierarchical space, right? So we can make certain assertions about the layout of the hierarchical space, and those assertions enable us to say that the backend, the archetype will have precisely one backend and so on. We don't have to worry about that. And that means this guy here now effectively will become the denormalized archetype properties. So we can get rid of that in 1 second. We just need to, well, let's just first sort this out. So nothing bad's going to happen now, of course, because all we've done is to add things, and adding things should never break anything. We just need to, oh, actually, sorry, I ran the wrong target. What I meant to run is generate. No, I meant to indent, I meant to convert. Now I meant to indent. Right, now then, usual hackery required in JSON models. And what you shall see now is that all tests shall pass. A bit of compiling towards the usual. See what's happening in the world. One thing that we don't really tend to make a lot of use of, but it does exist, is we have an RSC channel. Mainly seems to be just me, but hopefully at some point people will start coming around. I mean, one thing I've probably haven't mentioned a lot, but I mean, I haven't really made much of an effort to make Dogen a proper open source project. It is, until I finish my thesis, it's a bit difficult. But nevertheless, I've tried to create it as an open source project, so if people want to join, they can. Waiting for time, almost an hour. Righty, so that was good. Let's just get rid of all of this then. So physical add backend facet and part properties to archetype. So now then we've got all those properties. All we need to do is we need to look at our Metamodel Properties transform, and in here there's going to be a denormalized. Right, so in the denormalized, we already are doing all the hard work because of course we're denormalizing it, and because we are denormalizing it, all we need to do is to locate the archetype properties, which I presume will be here. There they are. And in the archetype properties we just need to add the corresponding things to it. So what we do is we'll just do an intermediate hack. We're going to say, for now, let's just update this guy here. This is just a sort of a three-step process, and to be honest, this is how I always like to do coding. I like to do this kind of like very, very small incremental changes to things, because it's easier when things break. You can easily see where they broke. I'm a very incremental coder. Right, so denormalized archetype properties. What we're going to do then? We're just going to basically say, find me the archetype. Bingo, there we are. And then what we need to do is we need to make sure this thing is not constant. And we just need to locate, well, let's just make sure that the whole thing is correct. So we're looping through backends. Then for the backends we find the facets. This could all be constant, it's not a problem. Eventually find the archetype. Okay, now with the archetype, all we need to do is this. You're gonna, it's not a pointer. Backend properties, right? Use the backend properties. Well, it's backend, isn't it? And then what is the facet properties? One thing we are missing, sadly, is the parts. And I think it's fine because for now we'll just put a fix me here so we remember it. What we'll do is put a fix me somewhere. We are not iterating through the part properties. And that's fine. We just remember that. The reason why, of course, if you can, we can imagine, we were in between one gigantic refactor, which is to do with parts and so on. And so the parts do exist, and they are kind of being populated, but not really. So you know, we're in a big loop of refactoring, so we just have to remember where things should go. Okay, so at this point in time, then, what's going to happen? Again, we're just going to quickly test that this doesn't break anything, and it shouldn't. It's going to populate the new denormalized properties, and then what we're going to then do is to say, whenever we are using the denormalized properties, please just consult the archetype properties. Okay, see, as you can see here, nothing broke. In fact, I'm going to just commit this because we are very incremental. So populate the new archetype, the new denormalized archetype properties. So that's fine. And now the second thing we're going to do now is we're going to go over to here. In fact, this might even go up to RG. We have RG somewhere. Yes, there we are. Let's just rename this to RG, or RG is fine. And what we'll do is we'll just do quickly a check for denormalized, whatever they're called. Is it denormalized? Let's just do a quick check to see who's using these guys. Now, as usual, there's going to be a lot of noise here, so we don't care about half of these things. Enablement Transform, clearly. And then itself. Metamodel Property Transform. Enablement Transform. and that is it. Okay, so really there's only one thing we need to worry about, which is the enablement transform. Let's have a look at the enablement transform. Right, so what we're doing at the moment is we're just applying to the normalized archetype properties as the global enablement properties, and I think we could probably just say yes. What we're going to do now is we're just going to basically say where are we using these guys. So we're using it in a couple of places. I'm going to try something very simple here. I'm just literally going to say don't use the normalized properties. I mean, we must have where are we, in the physical space? Yeah. So if you're in the physical space, we have a physical metamodel. If we have a physical metamodel, we shall have archetype properties. So therefore, if you're asking for denormalized, we shall give you the archetype properties. So entities presumably, we shall give you the global archetype. And to be fair, at this point in time, we don't really need the notion of global. We just need the notion of archetype. Archetype properties. So interestingly enough, we have archetype properties and the archetype. Archetype properties don't contain the archetype. Is that an ID? It is an ID. A bit silly, really. Let's just have a look at how this thing is being used. Why must we need archetype itself? I wonder if it's just for something silly like logging. Can't really see this archetype being used very much. It's actually just for logging purposes. Interesting that we are trying to compute the enablement for archetype. Well, okay, fine. It's a bit annoying, really. It kind of seems to imply to me that the archetype property should really have the meta ID. But then the question we'll ask is, why don't all of them have the meta ID? If you have to pass it around, it's not a good thing. Seems a bit silly. Of course, you know that because they were in containers before, we always had access to both at the same time. Right, how do we solve this? Shall we just do another quick detour? You already have a very easy way to get a meta name associated with all these guys. It would be a 5-second job to do it. You have to, sometimes you have to have a halting function to stop you from refactoring forever. Right, I think this is easy enough. Okay, so what we're going to do is, let's just very quickly. You can see how you can get yourself into a massive loop here. We are extremely quickly just going to do a very quick hack. Well, it's not really a hack, but all these guys here will now have their associated meta name. Right, and as you can see, this guy is just a little bit too big. So is the other guy, so nothing for it. We have to move these guys up. And then you can clearly now. This is one of the things I really wanted to put across. in these videos show you the realities of development as it currently stands, and you can clearly see here why I'm so annoyed at diagrams, because diagrams, as much as they're great as visual, intuitive ways of visualizing code, and the other thing to remember is the big thing about Dogen is structure. Really, we focus a lot on structure, and I think there's very few things in the world that allow you to see the structure of a program as well as a diagram. And because of the way our visual cortex is designed, we do lots of computations based on how things look, and that's a good thing. The problem is maintaining the diagram is a pain in the backside, which basically means that we really want the best of both worlds. You want to be able to see the visual representation, you don't want to maintain it. You want this to be an automated process. It's just too painful. Right, here we are. So now then, what's going to happen? We're going to quickly hop over to compilation. We're going to regenerate this diagram. Again, nothing major is going to happen here. All that's going to happen is that we're going to have a whole new set of properties, and I'm going to run a test. Nothing's going to happen. Right, so now then, while this is going, we should also think of how we're gonna. Oh, actually, one thing we've done wrong here is we started committing from here. Emacs doesn't like when you do that, because then your area doesn't keep its shape. That's why we have areas with everything. And it reminds me, we have references in a different frame. Skip it there. Right, okay, so what we want to do here is to say something like add meta name to archetype facet part and backend properties, and that's is the first step. The second step is, of course, to make sure it's populated. So if you go to the Metamodel Properties, not that guy, but the actual transform. Now what's going to happen here in the Metamodel Transform is that we're creating these chaps somewhere. We just need to make sure. Right, there we are. All of these guys have been created here. They're very straightforward, and we just have to go through it. So these are the backend properties, bp.metaname. Did we forget one? No, we did not. I think we just have a delay on. Oh no, there we are. And the backend properties are being populated off of a backend. So the backend. Interesting. We might have gone a bit too far. We went for the whole name. I think an ID probably would have been enough. Might have been a bit too much, really. I mean, do we really need a name? We should probably be conservative where we can, really. I mean, don't add things that you don't need, really. So what we really need is something like identifiable here. This is a complete name. I mean, we don't really need a name. So what we're going to do is create a new concept here. And we're going to call these meta identifiable. I mean, we call these concepts really, these are object templates, just so we don't confuse them with C++ concepts. And then we could just basically say, you have an attribute, call this ID. I mean, I could call it meta ID just to be very precise. Meta ID of the physical meta element. I mean, of course, you're probably going to say, oh well, why don't you just take the whole thing? But E3B, we should try to avoid taking more than what we need. So, of course, we need to say physical meta ID in the attributes. And away we go. Now then, we will just repeat the process we did for meta names. Another thing I'd never do, I mean at work I do this a lot, but I don't really spend a lot of time here doing uncommitting things and squashing commits and things like that. I don't particularly do that on my open source projects. Now, the main reason why I don't do that is because I actually find that history is designed to just record what happened, and at work you tend to think about how the commit's going to be reviewed and so on, all the sort of more other aspects of programming, I guess. You don't have to worry about any of that when you're working in your open source project. So instead, what I tend to focus on is to try to every commit should build, and the commits should more or less be faithful. They should be very small, and they should be very easy to review if you do need to review. You can't review the big picture, of course, but you can review the small picture. So if I have a commit that says, you know, this commit does XYZ, any person should be able to just look at the commit comment, should look at the commit content, and should be able to validate that the commit does what it says in the tin. Which is a bit different from what you're trying to do at work. Okay, so that all went okay. Of course, you're going to see now that we removed one thing, we added another. Doesn't really matter. That's what we wanted. So what you're going to say is, so what was that commit we had before? So replace meta name with meta ID in physical properties. Right, here we are. Now then, with all of that said, we can now easily go back to here and do a bp.meta ID, and the meta ID, unsurprisingly, is going to be right. Now, of course, see here we call this backend. This is not a good name because this is really not the backend. It's the backend ID. So that should be the backend ID, and that should be the backend ID. So we know what it means. Similarly, we will have to do the same exercise across the board. fp.id is going to be the facet ID, and this is the facet ID. And then the archetype will be similarly the archetype ID and the archetype ID. So all we've done so far is we populated the IDs, which is good. The next thing we need to do is we need to populate the denormalized, but again, remember, we just commit very incrementally, so all we're going to say here is populate. I mean, of course, you're probably going to say it now, didn't run the tests, but populate the meta IDs in physical properties. And what we'll do, so we can measure, is make sure the tests still pass. See the importance of having tests to execute quickly. We are already an hour and a half, close to. Excuse me. Right, so then, now we've done that. We're going to now very quickly just go back to denormalized, and there we shall apply our stash. Right, so then, denormalized properties populated here. Now, I think what we did wrong a second ago is we tried to actually replace the denormalized properties as part of this exercise. No, we have already populated that. Okay, cool. So then, what we need to do now here is focusing on replacing the denormalized properties in the enablement transform. use this guy here. So in the Enablement Transform, we no longer need to ask for the archetype's ID, we just need the archetype's properties and the artifact, which is quite nice actually if you think about it. What we're basically trying to say is give me the properties of this archetype and give me the artifact that you want to update. And if I now look for any references to the normalized properties, well, this guy is asking for every single denormalized property. And what else have we got here? So we've got physical metanames, biological metanames. We have denormalized properties, and we have the enable archetypes for a given element. We probably just need well, let's have a look at how we access all of this stuff. We have the PMM, and we have the normalized properties, which is the thing we're trying to replace. So some stuff comes from indices, which are coming from the PMM. Well, I think I'm just going to be lazy and supply the Metamodel properties, which are roughly all we need here, because this guy here at the moment has got the denormalized properties, and the denormalized properties are global for a given archetype, presumably, and then we must be obtaining just that archetype somewhere. Here we are. And once you got them, we just ship them over to the function that does the computation. Yes, laziness seems to imply we should have all of the Metamodel properties. It's a shame, really, that the Metamodel does not have this structure, because then I could just supply the entire Metamodel. In fact, that is it. All of this is the Metamodel. So let's look at this again. So why is it that we don't have access to the... Ah, yes, it's because part of it is in the Metamodel, part of it is in the model. So I think the right thing to do here is to supply the archetype properties. And that's exactly what we shall do. So let's just supply the archetype properties. It keeps the same logic. And that's what we want here. This will obviously be these archetype properties, and you can see here, now we're keeping the same idea that we had before. All we need to do is to say this guy here as the archetype properties. And then the archetype properties are the thing we look for. And so we locate the properties we're looking for. We have an I. The I is the thing we supply. And everyone is happy. And now, to complete our little refactoring, we need to take the archetype properties and now we just need to be very careful about the commentary here. So the archetype properties are global properties, so maybe you can just call this global and this local. And now we just very carefully gonna have to go through all these guys here. Right, so global dot overwrite, these are the archetype properties, And then I just have to make sure, this is very important, that we do not change the logic. So local dot override, and then we have to make sure that also another thing is be very careful there isn't a computed version of a property. As you can see here, we've already resolved things like whether something is optional or not, but hopefully this is not going to break the world. And local dot facet. Right, so okay, right, sorry, we made a mistake here. We made a very big mistake. We're not supposed to touch the local properties at all. These are correct. We just should only update the global one. So for the local properties, all we need to say is call this local. I mean, of course, you probably tell me that I could have used LSP's rename feature, and I tend to do that when I'm concentrating, but not at the moment. In fact, to be honest, what I'm going to do is I'm going to be lazy and just say anything that's LEP will become local. And I think we shouldn't have any spurious matches here, hopefully. Alright. Now then, the thing we're really interested in, the globals. So the archetype properties are global, or I mean, global is really not the right name, but if you see what I mean, meta versus instance. So, what do we have? Global dots. Now, should I be very careful what things are named here, as I was trying to say a second ago. So that should be override. And that should then be this guy here. Else, again, same thing, so global dot. Now you'll see there is no facet override, but there will be the facet properties. They would have their own override. So enablement for archetype. Now then, so bit of noise coming from downstairs. Should I just put this on pause for a second? I'm not sure if you can hear anything. Sorry, there's a bit of noise downstairs. Okay, so while you were away, sorry, I had to stop pause the video for a second. So while you were away, I finished the remaining replacements and ran the tests, and it looks alright actually. So what have we achieved then? We managed to remove all reference from the normalized properties, and because the test pass, that means that the information we had on the new data structures is equivalent. What we'll do is, just for good measure, just do a good regeneration of all the models, and you can see here nothing changed other than the stuff that we changed. Right, so what we've done here is we implemented, so implement Enablement Transform in terms of archetype properties, which is really good because now we've more or less proven that the archetype properties are equivalent to the denormalized properties, which is what we wanted in the first place. So now the second step is going to be to say, well, that being the case, what happens if we remove them? Now you see yet again my point about diagrams being constantly evolving entities, because a second ago we spent some time trying to get these things in the right place, and now if you look at the diagram it looks completely different from what it did a second ago. Don't really like too much space in the middle, so what we'll do is just refactor this guy slightly. project properties are almost the right size to fit underneath here. So we'll do a quick hack. Let's see how they look. Maybe one more. There you are. So at this point in time, what do we have then? One thing we did forget is to get rid of the denormalized properties. So then, in fact, probably really what we should have done, actually, in a good fashion, is we should have, before we do that, in fact we are going to do that. So you see here we have the physical model as it is at the moment. I'm just going to stash that for a second, and what we'll do is we're going to go back to the Metamodel Properties refactor, and we're going to get rid of the denormalized properties. So we're going to say populate denormalized archetype properties, and then this guy just populates denormalized archetype properties. Now, instead of having this as returning something, we'll just say that it's not returning something. And then the other guy will do something similar. If I could spell. And you can see now this is the sort of the last step of the process. And all you need to do is to make sure that where there was a return type, this guy here, there isn't one already. And in theory, it's as simple as getting rid of that. And finally, last step is to say populate these guys, and we are done. And now we will try to run tests for this guy. So in theory, all we've done now is we're no longer bothering to populate the denormalized properties. It's always the first thing you should do before you remove things. So you can split the commit. You see what I meant about this very atomic commits. It's almost like you are step by step, very slowly, very incrementally doing the changes. Now we can say something like physical do not populate legacy denormalized properties. Now then, we go back to where we were, and in here what we'll do is we'll just generate this guy, we'll convert this guy, and we will indent it, and then do the quick hack. And hopefully now, if everything is going according to plan, no one is relying on the denormalized properties. See, I didn't even bother to update the diagram because it was stashed. Now it's unstashed. Okay, good. Now whatever is left is things we didn't account for. So let's have a look what these things are. Okay. Clearly, we didn't do a very good job of removing the population, and again, this is something we do on purpose, really. When I said we don't rewrite history, I slightly lied. Cases like this, where it was just a typo, we forgot to remove something, very trivial, it doesn't really make sense to keep the commit as it was, really. I mean, it's really, really trivial, so it seems to me this commits, this is going to pass. So what we do in cases like this, where it's absolutely incredible trivial, we will uncommit. So we just have to keep track of what we're doing then. The transform we're interested in is this guy here. So all we need to do is to get that out again, obtain the transform, and recommit the commit, right? So all you're seeing here is what we've done previously. It's very, very trivial, and that's fine to uncommit and recommit these kind of commits, because yeah, so simple. As soon as it becomes any more complicated than that, you shouldn't really be faffing around too much. Nothing wrong with squashing, of course. Don't take me wrong. I do squashing on a daily basis at work. It's perfectly normal. I'm just trying to say that a different approach to squashing and to continually writing history and so on is just to have an extremely aggressive incremental history. Now, physical, remove, legacy, denormalized, properties. Right, so then, now you can see what just happened here. I mean, we went through one big loop. What time is it? It's almost... so we're approaching almost 1 hour and 40 minutes of coding, of videoing. So we went through this one big gigantic loop because we were in locator, and in locator we needed some denormalized properties. But we used that exercise as a way to reflect on the structure of the model. We figured out there were some deficiencies in the way things were being modeled. We corrected those deficiencies to an extent. We didn't really correct everything because we still have the denormalized properties in there, but that's fine, we know why. We did the sort of the quick fix. We put the denormalized properties where they should have been. You can see here this diagram is still not quite right. There's almost enough space to put these three guys here, but not quite. This is the annoyances. Yeah, we fixed that and we put things in the right places. So what we shall do, I think, is probably to stop here, because now we're going to enter the fairly complicated domain of trying to go back to the locator, and that's going to be probably another hour's worth of effort. So I think we probably should separate this into two videos, really. So okay, what we've achieved then is we got the properties in the right shape so that the locator can consume them. We fixed a whole lot of other places where these things are being used. Everything looks fine. And in the next video then we're going to try to then address the locator itself. Thanks for watching.